Hey everyone, in this video I'll show you how to bring an HDRI environment map to life by adding a dynamic sun sky in Unreal Engine. We'll set up an HDRI cube map material to work with a dynamic sun and create a sunset animation that's perfect for your architectural visualizations. You can download this entire pre-configured scene using the link in the description. Let's begin by preparing the HDRI texture. We need to edit it so that there is no sun on the map. Here's what the HDRI looked like before editing, and here's what it looked like after. Import your edited texture into the engine. Make sure it's in the HDRI format so the engine automatically treats it as a texture cube. Now we need to add a sky sphere mesh to the scene. In the content browser, find the static mesh sky sphere in the engine content. Place the sphere at the center of your scene and scale it up so that it covers the entire environment. In the Details panel for the sky sphere, disable the Cast Shadows option. This will allow sunlight to pass freely through the sphere's geometry and properly light your scene. Now let's set up the material, create a new material and change its shading model to unlit. To properly display the HDRI on our sphere, add a texture sample node and apply your HDRI map to it. Then create a Rotate About Axis node. This node will allow us to rotate the map around a specified axis. Create a constant 3-vector node and connect it to the normalized rotation axis input, setting the value to 1 on the Z-axis. This will allow the texture to be rotated around the Z-axis. Convert the rotation angle input into a cube map rotation parameter and leave the pivot point input as constant 0. Connect the absolute world position node to the position input. Create an add node. Connect the Rotate About Axis node to input A and the absolute world position node to input B. Then connect the result to a normalized node. Plug this entire chain into the UVS input of the texture sample node. Create a power node. Promote the exponent input to a parameter named HDRI contrast. Set default value to 1. This will allow you to control the texture's contrast. Next, add a multiply node. Connect a constant 3-vector parameter, which we'll call HDRI tint, to the B input. This will give you control over the sky's tint. Now let's move on to the main part, adding a dynamic sun to our HDRI sky. First, create the sky atmosphere light direction and camera vector nodes. Add a dot node and connect them to it. The dot node compares the camera's view direction with the light direction from the sun sky, which lets us determine when the sun is in view. Next, create a multiply node and set the B input to -1. After that, add a clamp node, setting the min value to 0 and the max value to 1. This chain of nodes processes the result to get a clean mask for the sun's disk. Next, create a sphere mask node. Connect the result from the clamp node to input A. Leave input B with a constant value of 1. Promote the radius input to a parameter named sun radius and set a small value, for example 0.00005. The sphere mask node uses our mask to create a visible sun disk. The sun radius parameter will control its size and hardness will control the softness of its edges. Create a constant 3-vector parameter node and name it sun color. Set default color to white. Connect to a multiply node in the same way. Connect to input A of a new multiply node the result from the sphere mask and the result from the multiply node to input B. This node multiplies the sun's mask by its color, allowing you to control the sun's color and brightness. Create another multiply node to combine this result with your overall material setup. Now use an add node to connect your HDRI map and the new sun chain. Add one more multiply node with an intensity parameter to control the overall brightness of the material. Set default value to 100. Connect the entire chain to the emissive color output. The material is ready. Save the result. Now create a material instance and apply it to your static mesh sky sphere. Adjust the HDRI map's position using the cube map rotation parameter. As you can see, the sun has appeared on our HDRI sky. To make this white dot look more like a real star, we need to increase its intensity. Increase the alpha value in the sun color parameter, for example, to 1000. Now the sun is bright and looks realistic. Now, when you change the sun's position within the sun sky system, our dynamic sun will automatically change its position on the HDRI map as well. To create an even more realistic effect, such as a sunset, simultaneously animate the sun's position and the tint of the HDRI map using the HDRI tint parameter. This will add a cinematic quality and greater realism to your scene. You can download the source files for this project using the link in the description. See you in the next video.